Hello viewers, and welcome to today's e-class. So today we are going to derive the equation for the total resistance, that is resistors in series. Total resistance for resistors in series. Total resistance for resistors in series. So we are going to consider three resistors. We are going to consider three resistors, R1, R2, and R3. This is R1, R2, and R3. Then from the resistors we have an ammeter, then we have a switch, then we have cells here. We have cells. So with these resistors, we're going to consider three voltmeters. So the first voltmeter is across the cells. Let's call it VT. That is the total voltmeter that is measuring the total voltage. Then we have another voltmeter, V1, another voltmeter, V2 against resistor 2, and another voltmeter, V3 against resistor 3. We have another voltmeter V3 against resistor 3. So with this kind of a setup, we are going to consider the path of the current when you switch on. So we know when you switch on here, current will pass through the ammeter, then through resistor 1, through resistor 2, resistor 3, and back to the negative terminal. So that will be the path of the current. And that tells you that current in each of the resistors is equal. Current is equal through each resistor because the same current that will pass through resistor 1 is the same through resistor 2 and through resistor 3 and back to the negative terminal. It's important to note that voltmeters have a very high resistance such that they will be able to minimize the current that can be able to pass through them. So in other words, current will pass through the resistors because the voltmeters have a very high resistance. So from here, we are going to form an equation of what is not equal. So it's important to note that we are saying current is the same through all the resistors, and that means voltage is not same. Voltage is not the same. If current is the same, voltage is not the same. And we form the equation of what is not the same. The equation of what is not the same. So it is right to say VT, that is the total voltage, is given by V1 plus V2 plus V3. In other words, the total voltage here is equal to voltage across resistor 1 plus voltage across resistor 2 plus voltage across resistor 3. And from that we all know from Ohm's law, we all know V is equals IR. From Ohm's law, we all know that V is equals to IR, and that means VT will be IR, but this time it will be TT, that is total current times total resistance. V1 will be, because we have said current is the same through all the resistors, we will not have current 1, current 2, and current 3 because current is the same. So we don't have any other current. So that means it will be, V1 will be I R1 plus V2 I R2 plus V3 I R3. That means you do not have I1, I2, and I3 because you are saying current is the same everywhere. So dividing through dividing through by current, I. Dividing through by current, since we all know total current is equals to the current. In other words, the total current through the circuit, this total current is the one that will pass through resistor 1, same current through resistor 2, through resistor 3, and back. So it will pass there as the total current. That means IT, which is the total current, is the same as the current we have here. So if you divide everywhere by current, that means what you have here is RT, total resistance, is equals to resistance of resistor 1 plus resistance of resistor 2 plus resistance of resistor 3. In other words, it is right to say total resistance for resistors in series is given by adding the resistors directly. You add them R1 plus R2 plus R3. Even if they are 5, just say R1 plus R2 plus R3 plus R4 and plus R5. So that's how you get the total resistance for resistors in series.